Hey, good morning. Welcome to Lesson 9 of SE301. My name is Dr. Vikram Mittal, and I'm the course director for this STAP course. So before we begin today's lesson, I just want to ask that if any of y'all have any feedback about the WPR, about the homework assignments, about anything that we're doing in this course, even how it's structured, and have any suggestions on how we can make it better, please shoot me a note and I'll be happy to have a discussion with you and hopefully try to implement some of the changes that you recommend. Again, we're always open to feedback, and that's how we get better. So talking about today's lesson, today we're going to be moving from problem definition into solution design. And we are currently in this third block of the course. We've done systems thinking and problem definition. So now we're going to move into solution design as well as look at design methods. And eventually, once we finish that, we'll move into the next stage with decision making and then solution implementation. So I'm going to break up this lesson into two blocks, so we'll have two separate videos. This first video will consist of a brief overview of value modeling, as well as looking at the solution design phase and then ideation. Block 2 will be looking at different design methods, as well as utility analyses. So when we talk about value modeling, we talk about two different types. We have a qualitative value model, which is shown on the left, and the quantitative value model, which is shown on the right. The qualitative value model is your value hierarchy. And the goal of your value hierarchy is to derive your value measures. So your value hierarchy starts out as your functional hierarchy. You take your top level functions that stem from your fundamental objective. And your functions are critical because they tell you what your system has to be able to do. From there, you derive your value measures, and these are your performance parameters. These are, hey, when you're looking at your different design alternatives, how are you going through what success looks like? Now, what we do from there is we create a quantitative value model. For each of those value measures, we have a value function. And what a value function does is it gives a score between 0 and 100 for each of those performance parameters. It basically tries to convert units. So in this example, you can see that one of your value measures is the thrust of the rocket, another is distance from target, and one of them has units of kilograms, another has units in meters. Your value functions allows all those to be normalized and converted to a score between 0 to 100, where 100 means that you met your objective, 0 means that you're at your minimum acceptable value. The next thing that you do is you factor in your weight. So each individual value measure has a different weight associated to it because certain value measures are more important than other value measures. And so you can use a swing weight matrix or you can use pairwise comparison. And either technique will give you weights that you can multiply by the outputs of your value functions to get an overall score for a different design alternative. And that's your overall goal. Your value model will allow you to evaluate and create a score, a value score for a given design alternative so that you can compare those different alternatives to each other. So when you're trying to build a value model, it follows a very definitive sequence of steps. So first off, you do your functional analysis for your functional hierarchy, and your stakeholder analysis, which is critical for determining what your value measures should be. After that, after you build your value hierarchy from your functional hierarchy, you derive your value measures. From your value measures, you then can create weights and develop your value functions. And again, just following the sequence of steps will allow you to determine an overall score for each of your design alternatives. All right, so now that we've kind of covered value modeling again, value modeling was the last step of the problem definition phase of the SCP. So now we're going to get into the solution design phase. So solution design consists of three sub-phases. It has idea generation, which we will talk about today. And this is where you try to figure out kind of broadly, what can you do to solve that problem that you defined in the previous step? And then from there, you start looking at alternative generation. And because you have a system, you have a lot of different components and trying to piece together what the ideal solution should look like. And then after that, you have your cost analysis where you actually try to factor in, hey, how much will this cost? I mean, You can probably get your dream solution and it's going to cost a massive amount of money. It's not really possible. And your output from your solution design phase is you have a number of different candidate solutions that then go into your decision-making phase. So your solution design phase is kind of driven by your problem definition phase because you know what your system has to be able to do. But you don't really use your value model until you get into the decision-making phase and you actually score out your different design alternatives. One thing I want to mention about the SDP and the importance of SDP and define the problem first. So for several years, I worked on a project. My sections heard me talk a lot about the Talos program. Basically, Special Operations Command decided to try to build an Iron Man suit. So Admiral McCraven had a Stoke got on television, said, hey, we're building Iron Man, allocated money for it, everything. Jumped right into the solution design phase. Our solution, Iron Man. Done. Didn't quite work out so well. We didn't really, the project actually ended up failing out 6 years and a lot of effort put into it. And one of the critical issues is that we didn't do that problem definition step up front. We we jumped right into solution design. We didn't know what problem we were trying to solve initially. We were trying to protect the first operator through the door, and we could have used systems thinking and kind of look at the picture holistically and try to understand, like, hey, look, why did we even have a person go through the door first? Why don't we do man-unmanned pairing, have a robot go through the door first? All this is saying is that one of the big benefits of the SDP is you make sure that you have the right problem before you move into solution design. And when you work on projects where you jump right into that solution design phase, you might be constraining your thinking or you might be solving the wrong problem. All right, so the first phase of solution design is idea generation. And right here you can see a very simple process for the ideation process. You have 4 blocks on here. You generate ideas, you refine ideas, you generate alternatives, and you screen alternatives. So when you generate ideas, it's brainstorming as well, or you can use some other techniques, but there's no bad ideas. You just think broadly and try to come up with possible solutions. After that, you refine them. It's like, you know what, there are wrong answers, and let's take out some of those. Let's add some more because I forgot about. You combine this solution and this solution, kind of create a hybrid solution. And you can use that to generate your different solution alternatives. And then you can actually screen those alternatives to determine, hey, these two things don't really work well together. So let's eliminate that. So when you're in that first phase of generating ideas, there's a number of different techniques you can use. There's brainstorming, brainwriting, affinity diagramming, and the Delphi method. So brainstorming, I'm sure every single one of you has done brainstorming in the past. You've probably heard the axiom about there's no dumb ideas while brainstorming. And basically it's just a conversation. People sit in a room, sit in a good environment. You normally have a couple of people, you normally have someone leading it, and you bring in subject matter experts and a lot of like just relevant people, and just talk and you come up with different ideas and you post them somewhere and you try to feed off each other and you kind of have that group dynamic going. You can have it structured, you can have it unstructured. And you can have it silent, where you don't talk at all. People are just writing things on boards. One issue that comes up with brainstorming, though, and this is very common for systems engineers and engineers in general, is you might have a lot of introverts, which means that you might have a couple of people that aren't introverts dominate the entire brainstorming process. So an alternative is brainwriting. So brainwriting is a form of silent brainstorming. And in it, you basically just write an idea on a piece of paper, and then you pass it in a circle to the next person, and that person can see your ideas as well as add their own. And you just keep passing it around and around, and you generate a number of ideas that way. So you get your collaborative effort, you have your group think, without necessarily having your without necessarily having those dominating personalities dominate the conversation. Another technique, and we talked a little bit about this during functional analysis, is affinity diagramming. Affinity diagramming is where you is very similar to brainwriting, but normally you do it on some sort of board with post-it notes. And what you do is you basically just write an idea on a post-it note and stick it up. And meanwhile, you have somebody moderating it all who kind of groups different elements together that are common. For Talos, we actually used a lot of affinity diagramming. I know during the initial conceptual phase, we spent about 3 hours affinity diagramming the suit and trying to figure out what all the suit needed to include. It's actually a great experience. It was actually not great. It was actually an interesting experience. We had a angry Navy SEAL who was heading up the project, just pacing back and forth on a conference table, yelling at us about how we're not using enough sticky notes as he locked us in this room for 3 hours until we created the solution that he thought was what it should be. Interesting process, but yeah, affinity diagramming is used in real life, and it's a very useful tool. And the benefit of affinity diagramming is that it allows for that collaboration, allows for that groupthink without necessarily having those individuals that are dominating it as part of the group dynamic. Another technique is called the 6 thinking hats, which I'll be honest, as a systems engineer, I've never used. I'm not exactly sure where it comes from, but it talks in the textbook. In it, it looks at the basic premise, though, is pretty sound of what the 6 thinking hats are. Basically, what it is that you have 6 people in a group, and each person puts on a hat. Sometimes it's the actual hat that they wear for this exercise. Your hat dictates what you should be focused on. So if you're wearing a blue hat, you're focused on process. If you're wearing a white hat, you're focused on facts. Red hat, you're focused on feelings. Green hat, creativity. Yellow hat, benefits. Black hat, cautions. And yeah, and then you switch hats around. We actually use something slightly similar to this for Talos. Normally, our project groups had our functional groups had operators, so special forces operators, acquisition folks, as well as engineers. And so you had some very different people working together. And to try to get us thinking in a different way, sometimes we would just switch roles. So you'd let the operator be the engineer for the day, and they would try to do certain things. You'd let the engineer be the acquisition person, and everything seemed to run more efficiently that way. And then the acquisition person be the operator, and that was yeah. Um, but yeah, it's a way to kind of change how you're thinking and make sure that you're covering a lot of different areas. Another method is what's called the Delphi method, and the Delphi method is common for very large projects, especially software projects. And what you do is you collect a group of subject matter experts, you ask them to fill out a survey, they give you back their opinions, and you take their results, you compile it, you process it, and then you send it back again and get additional feedback. And what it allows you to do is you kind of eventually, as you do this process, you converge on a series of results through that feedback. All right, so one of the big things that we have to make sure that we look at when we're doing solution design is we have to remember systems thinking. DSRP, big picture, gray box, all those things factor into solution design. So we have to make sure that we understand the big picture and encompass that bigger picture, encompass the holistic system. Make sure that you have feedback and you account for feedback in solution design. And you also have to look at short-term, long-term unintended consequences of what you're doing. That was again a shortcoming on Talos. We didn't really look at the more long-term consequences of armoring up an operator. We give him a superhuman suit with a massive amount of armor. Um, all the enemy has to do is respond by uh, booby trapping doors or putting ditches there that operators can't cross. So we didn't really look at some of those long-term consequences of the suit. We were just focused on building Iron Man. You can see on the SCP is kind of, that we also look at some of those ethics, and we capture them on some of these items in the external block. So you can see health and safety up here, moral and ethical down there, and legal down here. And the overall goal of having those things external SCP is just to make sure that those are things that we're taking into account when we're doing a process. So that wraps up this block of the lesson. Tune in for a second block where we actually talk about different design methods. And thank you.